So it's pretty simple still, but we're going to have some number attached to x squared other than 1. So let's do an example of y is equal to 2x squared. Okay, so I just drew the original picture here. So when you put in 1 in here, right? So let me make a table here, x and y. So when x is equal to 0, we still get 0. Okay, actually before I go on, let me label something very important. See this here? This point right here, where the graph seems to become pointy, has a special name. It's called a vertex. Okay, vertex. So we think of that as the starting point of the origin. So starting point of the parabola. So let me put x squared here and 2x squared here. So earlier, right, when y was equal to x squared, we already figured the values out. It was this. Is that okay? You guys recall that? When you square 0, you get 0. 1, 1, 2, 4. Squared negative 1, 1. Squared negative 2, 4. So what kind of numbers are we going to get here in relation to this column here? So these are the values of x squared, right? So here's 2x squared. How do I get 2x squared from x squared? All you have to do is
multiply 2.
Good. That's what's going to happen. So the x value does not change. Do you see that? Like it's still the same x values. So these x values don't change. What's going to happen is that the y value, instead of being 1, it's going to double. It's going to go up here. So instead of being 1, it's going to go up to 2. Instead of being 4, it's going to go up to 8. So the graph will get skinnier. Okay. Now, instead of using the word skinnier, skinnier is not a formal math word. Okay. So do you see how nothing changed about the x value? The y value went up twice as fast, right? So it was something changed vertically, nothing changed horizontally. So we call this a vertical stretch. Do you understand what I mean by how nothing in terms of x changed? We still plugged in the same x values. The y values came out twice as large. So it's the vertical that changed. Horizontal didn't change. So we call this a vertical stretch.